says which polynomial function has a leading coefficient of 1 and roots 2i and 3i with multiplicity of 1. Okay, so what I'm going to do is I'll read through the solutions that they presented on homework help and I'll verify through whether it's right or wrong and give you some of my tricks. Okay, so they're saying that to find a polynomial expression having 2i and 3i, and by the way, what are this I behind 3 and 2? So these are what you call imaginary numbers. So if you recall, we have real numbers and imaginary numbers. So for complex roots, so say for example, you're looking at x squared plus 4 and x squared plus 9, you can't really factor them out, right? Because in this case, if you have x squared plus 4, so maybe I can show you that. Okay, so if you have x squared plus 4, right, you can't really factor this because even if you have, let's say, x squared plus 4 is equal to 0, if you move that 4 to the opposite side of the equation, and this is very similar to x squared plus 9, you're going to see that this is a negative number and you cannot take a square root of a negative number. So that's why it's important to be able to have imaginary numbers for you to be able to have this x minus 2i and you have x plus 2i. So that's the reason why. And if you take a look at, let's see, okay, so coefficient of 1 and roots 2i and 3i with multiplicity of 1. So when they say multiplicity of 1, what that means is if you have, for example, a function y is equal to x plus 2, right? And let's say you have x minus 4 squared, right? So if you take a look at individual terms, say for example x plus 2, if your exponent is raised to the power of 1, that means it's a multiplicity of 1. However, if you look at x minus 4 squared, because it's squared, therefore your multiplicity is squared. And if we're looking at degree, just so you know, because multiplicity and degree is typically learned at the same time. So if you look at this function, x plus 2 times x minus 4 squared, the degree is going to be 3, right? Because it's multiplicity of 1 and you have a multiplicity of 2, therefore the degree is 3. So yeah, that's for multiplicity and degree. And because you want to be able to factor this, right? Polynomial function x squared plus 4 and you have x squared plus 9. In that case, when you write x squared plus 4 in terms of imaginary numbers, it would be x minus 2i and x plus 2i. And then when you're looking at x squared plus 9 in terms of imaginary numbers, it would be x minus 3i and x plus 3i. So that's why, let's see, which polynomial function has a leading coefficient of 1? And apparently they don't really write out our options. We don't have the options over here, so we can't really see what the other polynomial functions look like. So if you were to, I guess, match this, if you have this polynomial, then that means that would be x squared plus 4 and you have x squared plus 9. And in addition, as you can see, they're trying to specify what exactly a polynomial function is. So a polynomial function, as you can see, you have an, then you have xn. So this is just a formula, a general formula for you to follow, and you have real numbers 0 to n, right? And it says if you have degree n, that n would not be equal to 0. So when they say, for example, here, right, let's see. Yeah, so this n over here, because I know there is an an. So an is basically your leading coefficient in a polynomial function. That's just terminology. And then if you have, let's say, n over here, if this is not equal to 0, so let's say this was 3, then therefore it's a cubic function and your degree is going to be 3. So it's the highest power, basically, in a polynomial function. So yeah, this is your term, right? And within your term, you have what you call your degree, so the degree would be the highest power, and you have this number, which is a constant. So an is a constant that is multiplied to your x, x raised to the power of n. So let's say x raised to the power of 3. Therefore, an is going to be your leading coefficient because it's the constant that is multiplied to the highest power of x. So that's what a leading coefficient is. And then they're trying to look at complex roots. So this is just how we write complex roots. So typically you would see a plus bi or a minus bi. And in this case, they've used p plus iq or qi. So this is just a way to factor complex roots. And how did they arrive to this conclusion that it's x raised to the power 4 plus 13x squared plus 36 is equal to this? You just need to apply the FOIL method. You probably know this by now. So this is x squared plus 4, then this is x squared plus 9. So all you have to do is look at your outer function. So you have this, which is going to be x raised to the power of 4, right? You multiply x squared times x squared, and then subsequently, you're going to have x squared plus 9, x squared times positive 9, so that's going to be plus 9x squared, and then afterwards, you're going to have 4 times x squared, so that's going to be plus 4x squared, and then from there you can see that you can multiply 4 times 9, which is just going to be 36, right? And why is this 13x squared? Because you've combined 9 plus 4, right? So 9x squared plus 4x squared is going to be 13x squared, and you have plus 36, and this is basically x raised to the power 4. So, yeah, your degree is going to be 4, right? Leading coefficient is 1 because it's multiplied to the highest power of x, and let's see. Yeah, the multiplicity of x squared plus 4 is going to be 1, and the multiplicity of x squared plus 9 is going to be 1. So this is your polynomial function, and it's absolutely right. So okay, so the solution is correct.